Thanks for coming. My name is Zhou. I'm a PhD candidate in Technical Postdocs Lab at McGill University. It's my great pleasure to share our recent research on night owls and early birds based on population data sets. I have no disclosures. So basically, chronotype is an interesting behavior. It emerges from the synchronizations between our internal biological clock and the external clocks, such as the solar clock and the social clock. So chronotype refers to individuals' preferred timings for sleep and activity, which varies across the population. For example, the early birds and night owls. The early birds people are inclined to get up early and activity early, and the night owls people are more likely prefer to stay up late and activity late. And this variation may vary across the population, and it may arise from the genetics and also light exposures, age, sex, and social factors also have a huge contribution to this variation. And the chronotype really matters, and recent research has connected to many and various aspects in our lifestyles, as well as the cognitive performance, as well as the mental and physical health. But there is still a lot of inconsistent findings across the population, across the chronotype literatures. For example, some of them find the night owls people are highly or significantly associated with depression, but others don't support such significant links. So it reminds us there may be some chronotype subtypes, and each of them may have a distinct behavior and neurobiological profiles. For example, for the night owls people, some of them may have depression, but others may have not depressed. So this is our workflow. Based on our previous research, we included 27,000 people from UK Biobank participants, and all of them have a consistent chronotype scale across 2 time points. And they all have no shift work experiences. And we also regress all other sleep phenotypes, such as the sleep duration, napping, insomnia, and dozing. And yeah, so we implement a partial least square regression model. The input variable is 3 different neuroimaging modalities, including the structural MI, diffusion MI, and the resting state functional fMI. And the target variable is the chronotype scale. So this model can capture the maximum variance during those brain measurements and make sure those latent components have a maximum prediction power for the chronotype. And then to identify the significant components, we implement the 1,000 permutations. So in each iteration, we shuffle the chronotype scale, and it will generate the new distribution and compare the real model to this new model. We finally found 5 significant components here. And then we look more details to those components, and we found, and for each participants, they will have 5 brain scores. And the brain scores value indicated how strength participants align with one given pattern. And then we can correlate those brain scores to the participants' other measurements, including their behavior phenotypes, their clinical phenotypes, as well as their medicine usage. And also we did an external validation to validate if those subtypes are generalizable to another ages people, the children, or even another countries. So we applied those trained parameters to the children's brain measurements, and we also can get the brain scores for those children. And then we did the same thing. We correlated those brain scores with children's phenotypes. So here is the brain patterns for the 5 subtypes. And yeah, and we, based on their brain scores, we correlated their brain scores with their original chronotype scale, and we found the subtype 1, 2, and 5 is a night owl pattern, and subtype 3, 4 is an early bird pattern. And then we correlated those brain scores with the measurements to try to get their behavior and medicine patterns. So basically, for the subtype 1, the highlighted brain features are generated from the limbic system, such as cingulate gyrus, frontal cortex, especially the orbital frontal cortex, as well as the basal ganglia and the amygdala. And they are all like play very important key roles and in emotional regulation and reward system. So below is the behavior wide associations. And the first one is the phenotypes. And the second one is the diagnosis. The last one is medications. And this is a Manhattan plot for those association hits. So I summarized some important and significant hits here. So basically, the subtype 1 the pattern associated with the young age and have a high frequency of mobile phone usage and alcohol and tobacco consumption, and they have a low level of vitamin D, and but they have a higher cognitive test scores, and they have also a lot of emotional issues. So overall, this is a typical night owl subtype. And then for the second subtype, the subtype 2, we found the most significant brain features are derived from their diffusion eye. And all those major white matter tracts have a lower integrity. So by looking at their behavior and medical patterns, we found these subtypes are highly correlated with like smoking and depression. And they also using the antidepressants, so it confirmed this is depression-related subtype. And more interesting, those such as the smoking, hypertension, and cerebrovascular disease are all previously or known. It's correlated with the low integrity in the white matter. So this is a depressed night owl subtype. And for subtype 3, we found quite interesting. They have basically reversed resting state functional connectivity compared to the typical night owl pattern. And they also highlight the limbic networks. So basically, this subtype have a healthier behavior and medication patterns. So they have a lower alcohol consumption, they never smoking, and they have fewer emotional issues. And they have no diagnosis and medication hits. So basically, this is an early bird subtype. And subtype 4, we found this subtype is also significantly correlated with sex, and the female have a significant higher brain scores than males. And from their phenotypes, and we found this subtype people, they have a female special hormone pattern, such as they have a lower testosterone level and higher sex hormone binding globulins. And they also have lower alcohol consumption, but they have exhibited a little bit depression symptoms, and they were also using some antidepressants. So this is basically a more female-associated early birth subtype. And finally, we found the subtype 5 also have a significant association with the sex, and the male have a significant brain scores than the females. And from their behavior and healthy records, we found this subtype people, they have a special, male special hormone pattern, like they have a higher testosterone level and a lower SHBG, and they're also associated with high board patterns and some prostate cancer. And previous studies also found that the testosterone level is strongly correlated with those, such as board patterns and the prostate cancers. So basically, this is a more male-associated night owl subtype. Next, we applied our training model to the children's data, which is correlated from the ABCD data sets from the United States. And we also found for the typical night owl subtype, for children, they also associate with such as the European ancestry. We know our model are trained by the UK Biobank. They all, most of them are European ancestry. And for children, this subtype is associated with the old age, and they already heard the tobacco products. And the typical early birth subtype, they are associated with young age, and their body not began to change. But for subtype 2, we depressed the night owl pattern. We didn't find any depression symptoms in this subtype. This perhaps because we only use the gray matter volume for the children, but the most significant brain features are from the diffusion in our training model. And the children have a less mode disorders. They're most 3% in the BC dataset, but for the UK Biobank participants, the most 30% of them have a mode disorder. So it may be because of the data sets and also because we only have one of the kind of data issues. So yeah. So for the female associated subtype, we found they also exhibit the female related behavior in the children, such as the gymnastic behavior. And for the male associated subtype, we also found in the children those subtypes also associated with some male associated activities, such as the baseball, martial arts, and play video games. And finally, we try to understand the age distributions for each of those subtypes. And the left one is the children, and the right one is the adults. We divide the subjects into different age groups and calculate their average brain scores. And we found for the children, the younger children are more likely belong to the early bird, and the old children more likely belong to the night owls. But for the adults, the young adults more likely belong to the night owls. And if the older adults are also night owl people, they are more likely belong to the depressed night owl. So to conclude, our study find that chronotype is not a monolithic traits, and we identified 5 different chronotype subtypes, and especially the depression and the undepression people, they have different brain signatures. And the sex really matters for chronotype, and the male and female have different patterns. And also we confirm the chronotype shifts across lifespans. Yeah. Yeah. Thank you for your attention, and thank you for my collaborators and supervisors.
Thank you very much. Unfortunately, we don't have quite time for questions, but if you want to talk about this, speak a bit later after the session. And we are going to go straight to the next speaker, who is Jori van Haren from Maastricht University. And he will be talking about dissociating contributions of expectation and repetition suppression using high-field fMRI and MEG.